Okay, in this video, we're going to be moving on to section 2.4, where we're going to be talking about absolute extrema. Well, what's the difference between absolute extrema and relative extrema? Relative extrema just meant it was the highest or the lowest point in the surrounding area. Every point close to it was either higher or lower than it, depending if you're working with a minimum or a maximum. But the absolute extrema represent the absolute highest or absolute lowest point for the entire function over its domain. So if we were to look at a visual example here, and I had just a simple downwards facing parabola, this point up here would not only represent the relative maximum, because it's the highest point in the surrounding area, but it also represents the absolute maximum because it's the highest y value for the entire function. There's no other point in that function where I'm going to go higher than that because I'm just going down to negative infinity on either side. But if we looked at a different example, let's say a cubic function, and looked at, say, this point represents a relative minimum because it's the lowest point in the general area, but it doesn't represent an absolute minimum. Why not? Because I have plenty of y values over here that are all lower than it. The function eventually goes down to negative infinity, and all of those y values are lower than this y value right here. So it's a relative minimum, but not an absolute minimum. So there's actually lots of functions that don't have absolute minimums or absolute maximums. If we look at this quadratic function, this function has no absolute minimum. This specific function. This cubic function has no absolute maximum or absolute minimum. Why not? Because this function goes up to positive infinity, meaning there is no absolute highest value. And like we said earlier, it goes down to negative infinity, meaning there is no absolute lowest value. Another cool example of this is the function 1 over x. 1 over x, or x to the negative 1, has a graph that looks like this, where it has a vertical asymptote at 0 and a horizontal asymptote along the x-axis. What is the absolute maximum value? There is no absolute maximum value because the function goes up to positive infinity on this side. There is no absolute highest value where there's nothing higher than it. It just keeps going. What about absolute minimum? This graph is approaching 0 as I let x get really large, but it never actually reaches 0. I can always get closer to 0, and so therefore there is no absolute minimum either. So once again, there's lots of examples where the function doesn't actually have an absolute max or an absolute minimum. So that brings up a question of, is there something I can do to guarantee that I will have an absolute max or an absolute minimum? Well, it turns out, I'm going to look at this cubic function example again. There's a reason I used the dashed line, you'll see in just a second. If I restrict the domain to a closed bounded interval, let's say I start here, notice I'm using a closed dot because it's going to be a closed interval, meaning you include the endpoints, and I'll stop there. So if I restrict my domain to a closed interval, then does this function now have an absolute maximum? Well, if my function stops here, then now this point represents the absolute maximum. No other point gets higher than that because I'm stopping the function there. And this relative minimum ends up being the absolute minimum because I'm not counting any of those values because I'm restricting the domain to only this specific section. So if you restrict the domain of and I guess I need to specify this is only true for continuous functions, then the function will have an absolute minimum and an absolute maximum. It's guaranteed to have both. And this is, of course, assuming that the function is continuous over that interval. And we'll actually see an example in the examples video where that comes into play. So if I'm guaranteed to have an absolute minimum and an absolute maximum, the next question is, where do I find those? Where do I find my absolute minimum and my absolute maximum? Well, we can look at my example here to get an idea of where we should look. Where did we find the absolute maximum? The absolute maximum occurred at one of the endpoints. Where did we find the absolute minimum? The absolute minimum occurred at one of my critical points, or one of my relative maximum or minimums. So these represent the two different places you should look for these absolute minimums or absolute maximums. So absolute extrema can occur at endpoints and critical points. So if you have a function with a closed interval as its domain, then I know that my absolute extrema can occur at that left endpoint A, the right endpoint B, or any C value in the interval such that C is a critical point. So now that I know where these absolute extrema can happen, how do I decide which ones are the absolute maximums and which ones are the absolute minimums? Well, remember, absolute extrema is all about the absolute highest point and the absolute lowest point, which all depends on what your y values are. So to test this out, all I'm going to do is find what the function value is at A, what the function value is at B, and what the function value is at any of your critical points that are within your interval. Whichever one has the highest function value is your absolute maximum, and whichever one has the lowest function value is your absolute minimum. And that's all there is to absolute extrema. So go ahead and try a few problems on your own, and then I'll go through a couple examples in the example video to show you what this looks like in action. Okay, good luck, and I'll see you in the next video.